Welcome to a new video where I'm going to show you today how to carry out function differentiation using Mathematica. I've compiled a short list of problems and I'm going to go at them one by one. So the first one is we're required to find both the first and the second derivatives of this simple polynomial, and the Mathematica command to find derivatives of functions is simply d, as the letter suggests. So you write d, capital letter, and then you have your square brackets indicating that this is a command of Mathematica, and then you start typing in your function, right? So this is x cubed plus 9x plus 2, and then you need to tell Mathematica that the variable you're interested in differentiating with respect to is x, and then you run the command, getting 9 plus 3x squared, which is what is expected. Notice how Mathematica decided to write the higher degree variable here at the very end and the variable x to the power of 0 at the very beginning. However, if I am interested in finding not the first derivative but a higher order derivative, the second for example, what I'm going to do is I'll copy this line of code, paste it here, and this time I'm going to indicate that I am still interested in differentiating with respect to x, but I'll have here a comma and then a 2. This way I'm indicating that this is the second derivative, getting 6x. If I were to find the third derivative also, I would write here 3 and run the code, getting 6. Finally, of course, the fourth derivative would yield a 0. So this is what we have. The same thing exactly could be done for, of course, trigonometric functions. So I write d, and then remember that sine of x itself is a Mathematica command, so you have to write the first letter, the s, in uppercase letters. So sine of x and then comma with respect to x. I get cosine of x. Let's try this here. So derivative of the cosine of 2x squared with respect to x, yielding negative 4x sine 2x squared, which is the result that we're expecting. Let's try it this time for the tan of the square of x. So tan square root x, right? This is what we get. And finally, I'll do the same for the sec inverse, keeping in mind that the way Mathematica understand inverse trigonometric functions is that you'd have to input them as arc. So this is arc sec of e power x. The way to write e is one of two things. You can either write exp, which is another Mathematica command, so exp of x, getting this answer, or what you could also do is typing in right away the e function. The way to do this would be pressing on the keyboard on the escape button, followed by a couple of e's, and then another time on the escape button. This automatically converts it into e, and then you do the usual power. So I write here x, and I differentiate, getting the same exact answer that we got from here, right? And yeah, that's it. I hope you've enjoyed the video.